What logic gates are used in a basic calculator? Imagine a tiny digital brain inside your calculator that helps it perform math instantly. This brain is made up of tiny electronic switches called logic gates. These gates work together to do addition, subtraction, and even more complex calculations. But which logic gates are actually used in a simple calculator? Let's find out. A basic calculator mainly relies on four types of logic gates: AND, OR, XOR, and NOT gates. These gates are the building blocks of digital circuits. When you press a number or an operation button, these gates process the signals to give you the answer. The core operation in most calculators is addition, and these gates are perfect for that. XOR gates are super important because they add to binary digits and give the sum. Think of them as the digital version of the exclusive, or they output a high signal, which means 1, only when the inputs are different. So if you input a 1 and a 0, the XOR gate outputs a 1, just like adding 1 and 0 in binary. Next, AND gates come into play to find the carry. When both inputs are high, the AND gate outputs a high signal. This is like when you add two ones in binary, and you need to carry over to the next digit. The AND gate detects that both bits are 1, so it produces the carry. OR gates are used to combine carry signals from different stages. When multiple bits are added, the OR gate helps to pass the carry to the next stage if any of the previous bits generated a carry. This makes sure the calculation flows smoothly across multiple bits. NOT gates, also called inverters, flip signals from high to low or vice versa. They are used in subtraction and to create more complex logic like NAND or NOR gates. For example, in subtraction, the calculator might invert bits to perform 2's complement operations, which is a way to subtract numbers in binary. All these gates are combined to make full adders. A full adder is a small circuit that adds two bits and a carry-in, then produces a sum and a carry-out. Multiple full adders are connected to handle larger numbers, like the 4-bit numbers in a calculator. When it comes to subtraction, these same gates are used with additional logic. The calculator inverts bits using NOT gates and adds 1 to perform subtraction through 2's complement. This way, the calculator can handle both addition and subtraction with the same basic components. More advanced calculations like multiplication and division are built from these simple gates arranged in more complicated circuits. But at the heart of every calculator are the AND, OR, XOR, and NOT gates. They work together to perform the basic arithmetic operations that make your calculator work. In digital electronics, these gates implement Boolean algebra, which is the math of true and false. They turn simple yes or no signals into complex calculations. Embedded systems in calculators relying on these tiny gates to process data quickly and accurately. So next time you press a button on your calculator, remember that it's all thanks to these tiny, powerful logic gates working behind the scenes.